the nitrogen cycle. Life needs nitrogen, from bacteria to plants to bunnies. In nature, only certain bacteria can fix atmospheric nitrogen into something that all other life forms can use. Before Haber, nitrogen was so precious as a fertilizer that bird and bat guano was a precious commodity. After Haber created the first method to artificially fix atmospheric nitrogen, nitrogen-based fertilizers allowed for the production of more food than anyone thought possible. This is why we aren't all dead of starvation, despite a population explosion that makes rabbits look chaste. So the nitrogen cycle is fixed, right? We've totally got the system worked out. Wrong. Our changes to the nitrogen cycle have created a new set of problems. Nitrogen fixation is an energy-intensive process, which contributes heavily to global warming. And the fixation process produces methane, which is a potent greenhouse gas. And runoff from nitrogen-based fertilizers is one of the most dangerous pollutants in our water. It's poisonous if consumed and leads to algal blooms in waterways that destroy marine ecosystems. Fortunately, Wellesley, Babson, and Olin are all teaching their students the skills needed to help solve this problem. Let's see what they're working on. I know that it may not look like much now, but this is the future site of the Wellesley Forest Garden. Wellesley's contribution to gardening without using any nitrogen-based fertilizers. So basically, once we're done here, we should have a garden that has the same biomass density as a forest and the same low maintenance needs as a forest. So, with the idea that we'll have fruit and nut trees acting as the canopy, fruit-based vines growing up them, bushes everywhere. We've got a lovely blueberry patch, and as much of a supporting network as we can get, which includes a whole lot of nitrogen-fixing plants. Mind you, we're not going to be getting as high yields as we would if we use nitrogen-based fertilizers, but it more than makes up for it in low maintenance costs. And since we've got so many plants growing here, as biomass dense as a forest, we should be able to get appreciable yields to using nitrogen-based fertilizers. Well, at least in terms
At Babson College, one of the things that we're doing to fix this nitrogen cycle is the factor of sustainability. At Babson, one of the things that we focus on sustainability, for example, is like trayless trim, where we try to reduce our food consumption, which ties into the nitrogen cycle. Other things that we also have been able to implement with the sustainability of this issue is also cardboard recycling as well at Reynolds. We also have sustainability courses at Babson, where students are able to incorporate the sustainability and fixing the nitrogen cycle into their business models. For example, in the Green Tower, students are always pursuing business ideas and concepts that are always going green and always helping the environment.
As part of Olin's contribution to the fixing of the nitrogen cycle, there's a class being taught called Microbial Diversity. This is the first time that this class has been given. And as part of this class, students have gone out and found bacteria and sequenced their genomes. This particular bacteria, which is a nitrogen-fixing bacteria, had its genome sequenced, and it was found to be a new species, not previously documented. So the use of bacteria like this to fix nitrogen, instead of the conventional Haber process, which is extremely inefficient and contributes largely to our overuse of fossil fuels, would be a much better alternative for creating fertilizers and the nitrogen that's used by the food that we eat.